Hello friends, welcome back to my YouTube channel. Today we are going to continue our discussion on the pointers variable. In this particular video we are going to discuss about the various mathematical operations that we can perform on the pointers variables and what are the things we should avoid to perform on the pointers variables. First, let us discuss about the addition of a number to a pointer. So here we have what we have done. We have one integer variable called a is equal to 10, and then we have declared integer pointer ptr. We have assigned the memory address of a, and we have written two statements. One statement we are adding +1 to the pointer variable. In the second statement we are adding 3 to the pointer variable, right? So if we want to know what each of the statement is doing, first two statement we have already covered in our previous video. So whenever we are declaring a memory, we know that suppose a has a memory address of 2000, and here we are storing the value of 10, and here the location name is a. Similarly, ptr will be a pointer where we are going to store it in the memory. Suppose ptr getting a memory address of 6000, and then we are storing the location of a, memory address of a, that is 2000, and this name will be ptr, right? Up to this one we are clear as per our previous discussion. Now what we are adding to ptr plus 1, ptr has become ptr plus 1. So now here in the statement what we know, ptr is always points to the memory address, right? Whenever you are adding 1 to that memory address, what it would happen? Initially I told you that this data type is very important whenever you are declaring or storing the address of that particular data type to a pointer. This data type, why it is important? Because now pointer is always pointing to the memory address, right? So whenever you are performing this particular statement, what it will be converted to? So here we are going to update the memory address stored by ptr. So here what memory address it is storing? 2000. Now we are going to ask the compiler, please perform the operation 2000 plus 1, right? What does 1 mean? This 1 is nothing but it is an integer pointer, right? How much integer pointer occupies in the memory? 4 bytes, right? So whenever you are adding a number to a memory address using this pointer variable, it will jump to the next integer location, which is nothing but, if you want to store consecutive integer in the memory, how the memory map will look like. Suppose this is the whole memory map. Right here you have 2000, right? Next pointer will be, next integer will be stored as 2004. Third one will stored as 2008. If you are continuously thinking about the memory space, here it is 2012, here it is 2016, right? So how the statement will work here? As first time we have performed that ptr is equal to ampersand a, which is nothing but 2000. Whenever you are adding a number and it is the integer pointer, it will jump to the next location where the compiler can store an integer value. So here 4 bytes it will jump, so directly it will come to a 2004. So now after this statement, the ptr will look like, suppose this is the pointer variable memory location will not be changed, so it will be 6000. So what address it will be pointing to? It will be pointing to the next location where the next integer may get stored. So it will be 2004, right? You got my you got the point, right? When you are declaring a pointer variable and performing this type of operation, it is not a normal mathematical operation. You are adding you are asking the compiler to go to the next memory location by doing a +1. So what will be the next memory location? If it is 2000, it should not go to 2001, because already the a, how much bytes it has occupied? It has occupied 4 bytes, and that is integer pointer, so it should always point to the memory address where next integer will be stored. So this +1 will be executed such a way that where it will go jump to the next memory address. So it should go to the 2004, because 2000 to 2003 are occupied by a. So in this case, the memory pointer value will be changed to 2004. Now if you go to perform the next statement where pointer +3, so already pointer is in 2004. So now we are asking to go to the next consecutive after the 3 consecutive memory address, after what the next integer will be stored. So here this will be the first one, second one, third one, right? So now it will come to this point where it will point to the fourth integer, right? Pointer plus 3 means already pointed is 2004, next one will be 2008, after that it will be 2012, then it will be 2016. So pointer plus 3, where it will be locating to? It will be locating to this memory address where the compiler may store another integer. So while performing this particular statement, what the what the pointer variable will store inside the pointer variable, the location of the pointer variable will not change, but the value of the pointer, now it will point to 2006 memory address, 2016 memory address. So it is very simple way you can think about. Whenever you have a integer pointer, that means it is pointing to integer memory address. Whenever you are performing any mathematical operations by adding numbers to the pointer variable, always multiply 4 to that particular number, because if it is integer, it will occupy 4 bytes. So now if the pointer variable is storing, suppose example 2000, instead of 2000, suppose it is storing 10,000, so next address will be 10,004, 10,008, 10,012. So simply you just multiply 4 with this number and add it to the memory address where it points to. So as it is 2004, so after adding 4, it will be becoming 2004. Here we are adding PTR plus 3. Already this statement has executed. So now pointer will be having 2004. So now how much we have to bytes you have to add here? 3 into 4, because each of the integer will be occupying 4 bytes, because pointer is always 4 bytes, so it will always jump by 4 bytes each time you are adding a single number. So you have to multiply 4 with it. So now the next address location, it will be pointing to 2016. So if you print this address using the printf, first statement, here you will get 2000, here you will get 2004, here you will get 2016, right? So this is the way the pointer addition will work. Now we'll discuss if it is instead of the integer pointer, if it is become a character pointer, because character pointers points to the character variable. Now we'll see that how this statement will work. Here we have declared a character variable alpha is equal to a, and then we have declared a character pointer cptr, and we have assigned the address of the alpha variable here. Now we are performing two mathematical addition operation here. Cptr is equal to cptr plus 1, and the next statement cptr is equal to cptr plus 3. So now let us see how it will work in terms of your memory space. So similarly, as per our previous discussion, like integer character variable also will get a memory. So suppose the character is starting here with 3000. Here the location name will be alpha, and we will be storing the value of a here. And this is the pointer variable. Suppose the pointer variable is getting a memory address of 7000. And what we are storing in the pointer variable, character pointer variable, the address of the alpha variable, that is 3000 here we are storing, and the name of the location of the pointer variable will be called as cptr. Up to this one we have already discussed. Now let us see how this statement will work. This is a character pointer, right? Characters are always 1 bytes in the memory space. So if you think about, if the compiler are only storing the character variable in the memory, how the memory map will look like. Suppose these are the various character variables stored in the memory, and this is starting with the location of 3000. So what will be the next character variable address that it can be get into the memory? That will be 3001, right? Because it's each of the character will be getting 1 byte each. So this will be 3002, 3003, and this will be 3004, right? So once you now how this statement will work. This cptr will return, this is it is returning 3000, right? Now we are going to ask the compiler to go to the next location where we can store another character variable, because it's a character pointer. So it will always points to the next location where another character address is available. So whenever you are performing this operation, you are asking the compiler to go to the next location where you have another character variable. So as character variable is 1 byte, so how much byte it will traverse? It will go to the next location, which is nothing but 3001. Again I am repeating the statement. whenever you have a character pointer and you are performing a addition operation of 1 to the character pointer where it is storing a character variable address, this will convert it to the 3000, and you are asking compiler go to +1 means go to the next character location in the memory. So next character location, if you are consecutively thinking the characters are stored in the memory, it is the 3001. So the value stored will be inside the pointer variable will be, the location of the pointer variable in the memory will not change, it will be 7000, and instead of 3000 it will now point to 3001, right? Now if you come to the next statement where we are asking the compiler to perform the next statement, cptr is equal to cptr plus 3. So we are asking the compiler to go after the 3 consecutive character location in the memory. So now it is pointing to here 3001, so this will be the first, second, third. So now it will be pointing to 3004. How it is coming? Because cptr is already pointing to 3001. The next character location will be 3002 because each character is 1 byte longer in the memory. So after addition of 3, it should go to the 4th location where the 4th pointer will be 4th character will be stored in the memory location. So it will be 3004. So here, if you think about the memory map of the pointer variable, the pointer variable memory map will not be changed. It will be 7000 in the memory it will occupy, and then what value it will get stored inside the memory, inside the pointer variable, it will be 3004. In the previous example, we saw that in case of the integer variable, it is traversing 4 bytes because it was an integer pointer. Integer pointer points to always the integer memory address. Each integer variable occupies 4 bytes in the memory, so it jumps each time 4 bytes. That's the reason I told you initially that data type of the pointer variable is very important, because it should match to the data type of the variable for which particular variable's memory address is getting stored inside the pointer. Because whenever we are performing any mathematical operation such as addition of numbers to the pointer variable, it always go to the next location where the similar data type can be stored in the memory. So for simplifying this statement, as character is 1 byte, so you can multiply with 1 here with this particular mathematical number. So whenever suppose you have a addition of cptr plus 10, so you can multiply with the 1 because each of the character will be 1 byte, and it is going to the traversing to the next location. It will not jump to any other location by doing this mathematical addition. So it will go to the 3010, right? So that's the way we can think about how the memory traversing will happen using the pointer variable, and which particular memory location it will point to after performing a addition operation with a number to a pointer. Now let us discuss about the subtraction of a number from a pointer. Here we have given a statement integer, we have declared a integer variable a is equal to 10. So the memory will be looking like, suppose it is stored in the 3000 and we are storing here 10, this location name will be a. This statement we are declaring a pointer variable, integer pointer variable, and we are storing the address, memory address of a. So it will look like this is the pointer variable. Suppose it is getting 8000 in the memory, and what value it will be stored, 3000 inside the pointer variable, and the name of the location will be ptr. Now look at this statement. Here we are performing a subtraction operation, ptr is equal to ptr minus 1. How it will be converted into the memory address mapping. Suppose there is a memory map. This is the whole memory map you are thinking about, and here suppose this is 3000. Okay, how much it will be? 2996. Here it will be 2992, and this location will be 22988, and this location will be 3004, this will be 3006, this will be 3010, right? This is the memory map where we are assuming that compiler is storing the integer variables in consecutive memory spaces. Now think about this statement, ptr is equal to ptr minus 1. So how it will be converted to, now ptr is pointing to this memory address, right? So it will be like from 3000 memory address, we are asking the compiler to subtract 1, where ptr is a integer type pointer, so it is pointing to the integer memory address. So whenever you are subtracting 1, so it will go to the previous location where another integer may get stored. So if it is 3000, so what will be the previous location where the another integer variable can store? It is 2996, because this will be the starting location for the another integer, right? Because it will get 4 consecutive bytes in the memory, right? So it will always jump to the previous location where the another integer can get stored. So this will be converted as, this will be, this after the statement it will be 2996. So if you think about the pointer memory variable memory map, so it will be like 8000 in the memory, and what value it will be stored inside the pointer variable, instead of 3000 it will be 2996. So 2996 will be nothing but the previous memory address where the another integer can get stored, and that will be the starting memory address of the integer. Now if you come to the next statement where we are asking the compiler to perform ptr is equal to ptr minus 2. So we are asking the compiler to go back to the next 2 location where another integer can be stored. So here currently we already know the pointer is pointing to 2996. So this statement, here we already know that the pointer is currently pointing to 2996. So this statement, what we want to do here, we are going back to the 2 previous location where the another integer can be stored. So this minus 2 will not go just deduct from the 2996. It will be nothing but the 2 previous location where the another starting location will be the another integer variable. So what it will be doing, so this will be the first location and this will be the second location, right? So this will be the starting location for the another integer. So this will be yielding the result of 2988. So what will be the starting location for the another integer after deducting 2 from this pointer variable? So it will be nothing but, it will be yielding the memory address of 2988. So now if you are store how the pointer variable will be looking like in the memory, so pointer variable address will be 8000 instead of 2996. Now it will be pointing to 2988. So what we have seen here, whenever we are doing a addition or subtraction operation on the pointer variable with a number, what it is doing, it's not simply subtracting the value from the memory address is pointing to. It always thinks that it has to go back to the similar data type memory location where it can get stored into the memory. So for simplifying this calculation, what you can do, you can multiply with the pointers are 4 bytes, so you can multiply in this way. Like now suppose it is pointing to 3000 and you are deducting 10 from this one, so 10 into 4, right? Because each character, each pointer, each integer are 4 bytes longer in the memory, so the location it will be pointing to, just simply now you can subtract the numbers, so it will become like 2960. So with the subtraction operation, we have seen that for a integer pointer, it will always point to the previous location where the another integer variable can be get stored in the memory. Now let us see how this subtraction operation will be performed to a character pointer. Here we have declared a character variable alpha is equal to a, right? So suppose this character variable is getting stored in 5000. This is a, this is alpha of the location. This location name is alpha, and this pointer is pointing to the memory address of alpha. So suppose this pointer is getting started in the location of 9000 in the memory, so it is storing 5000 here, and the name here cptr, right? Now what's the next statement? Cptr is equal to cptr minus 1. So if you think about the consecutive memory space in the memory where we are storing the character variable, so suppose this is starting off 5000, so this will be 5000, this will be 4999, 4998, 4997, this will be 4996. Similarly it will be like 5001, 5002, and it will go on. So currently the CPTR is storing the value of the address where A is stored, so here it will be like 5000, right? So after what it will the statement will do, so it will be converted to 5000 minus 1, right? So here we are asking the compiler to go back to the previous location and for where another character variable can be stored in the memory, because this is operation is performed on the character pointer. So character pointers, as the data type is character, always it will point to a location where another character variable will be stored in the consecutive memory space, because we are doing the subtraction operation. So as character variable is 1 byte longer in the memory, so what it will do, it will go back to the previous location where another character variable will get stored. So 5000 minus 1, another character variable will start in the memory with the location of 4999. If you are thinking of the consecutively we are storing the character variable. So the pointer, now how the pointer memory map will look like, the location of the pointer will be 9000 in the memory, and what value it will store instead of 5000, the value stored inside the pointer variable will be 4999. And if you are performing this operation, cptr is equal to cptr minus 3, so now it is 4999 minus 3. So here 3 is not a single number. Here we have to think about in terms of your memory map, as it is a character pointer, so it will always point to the character memory space. Now we are asking the compiler to perform where it will go back to the 3 memory address location behind where another character variable can be stored. So this is the now the current location, so it will go back to the first location, second location, and this will be the third location. So after performing this operation, what will be the resultant value of this address subtraction? It will be like 4996. So in the memory map of the pointer variable, it looks like it will be looking like the 9000 will be the pointer location in the memory, and what value it will get stored inside the pointer variable, it will be 4996. We have seen here, depending on the data type of the pointer, the mathematical operation of subtractions or additions works on the pointer variable. So whenever it was when you are performing the mathematical operations for subtraction or addition to a pointer variable of integer type, it will go to the next integer location. So you have to simply, to calculate the memory address, you have to multiply 4 with the number you are doing addition or subtraction. And when it is a character pointer, as character pointer always points to the character variable, and each character is 1 byte, integer was 4 bytes, so for character variable you have to multiply with 1. So simply you just simply deduct the same number to the memory address is currently pointing to. This is the way the mathematical subtraction and addition works on the pointer variable. I'm going to discuss a very interesting thing. If you are suppose subtracting one pointer from another pointer, what will be the resultant thing? Here we have declared a integer variable a and storing a value of 50, right? So we are always going to represent in terms of your memory map. So suppose here you are storing in 2000 the location, the value is 50, and the name of the location is a. The next variable is b. We are storing the location of a into the pointer variable. Suppose this is the pointer variable, and now here the location of the pointer variable, suppose it is 8000, and here we are storing the memory address of a, so this is 2000, and the name of the location should be ptr a. Now in this statement what we are doing, we are declaring another integer variable, and that variable, if you think in the memory, so suppose this variable is getting stored in 2050, right, in the location, and here we are storing, suppose this memory location is 2000, instead of this memory location is 2300, and here we are going to store 20, and this memory location, the name of this location will be b. And this statement what we are performing, we are declaring another pointer variable. This pointer variable is ptrb, so it will get a memory location. So suppose this memory location is 9000, and what we are storing, the address of the location b, so memory address of b is 2300, so here we are storing 2300, and the location should be, this name of the location will be ptrb. So these are the 4 initial statement we have. Now what interesting thing we are doing here, we are subtracting the pointer a minus pointer b, right? So what it will do whenever you are subtracting these numbers, so pointer a is nothing but it's pointing to a integer memory address, and pointer b is pointing to the memory address of another integer pointer. So always remember, when you are going to perform this type of operations on the pointers should be of the same data type. like if it is an integer point, whenever you are performing the subtraction between two pointers, the both of the pointers should be of the similar data type. That's the reason here we have performed the operation on the integer pointers. You cannot perform this type of operation with an integer pointer versus character pointer, because that will throw compilation error. So the subtractions of the pointers can be performed on the pointer variable of the similar data type. So here, now let us see how this will be interpreted in terms of your compiler language. So ptr A is nothing but it is 2000, right? And then we are subtracting with 3000. We are going to get the difference between these two memory address. So 2000, so ptr B is nothing but 2300, right? So theoretically, if you go perform the normal mathematical operation, it should yield 100, right? Because this is the difference between two, as the memory address doesn't have any sign, should not be printed, so it should be 100. We can take as the absolute value. So this is the difference between these two memory address. But what actually this memory pointers usually do, it points to the integer pointers memory address, right? Integer variables memory address. So as integer variables are 4 bytes longer, so whenever you are performing this operation between two pointers, whatever the difference will come, you have to divide with the 4, because each pointer, each time with the addition of subtraction we have observed, we have seen already, integer pointer traverse 4 bytes each time whenever you are performing a mathematical operation as subtraction or addition. Similarly, when you are going to perform this type of subtraction between two integer pointers, definitely the value, resultant value will be traversed in each time 4 bytes. So if the difference is 100, so we should divide with 4, so the resultant value will be 25. So it is not the exact difference between the memory address, it will give you the number of integers that can be stored between this memory address. So when, again I am repeating my statement, whenever you are performing the subtraction between two pointer variable of the similar data type, you have to imagine that it's going to give you the result of the number of the similar data type can be stored where it's pointing, suppose pointer is pointing to the integer variable memory address. So it is always should give you the resultant value where number of integers variable can be stored inside that particular memory space between these two pointers. So how many integers can be stored between these two pointers where it is pointing to 2000 and 2003 to 2000 and 2300. So 2000 and 2300, between these two memory space we can accommodate 25 integers, because each integers are 4 byte. So the resultant value of this operation of the subtraction between two pointers should give you 25, not the exact value between the difference between the memory difference between these two pointer variable. So whenever you are performing this operation, you always divide with the 4 with the result with the subtracted value, and then you will get the resultant value of this operation. Now what is this statement? We know that this is the value at address operator, so star ptr A will be 50, right, and star ptr B will be 20, because now we are performing the mathematical operation on the two numbers. So what will be the resultant value? It will be 30. So here it is very straightforward calculation, where star ptr not will going to give you the memory address, it is going to give you the value at the memory address, so that is 50. Here it will be like value at the memory address of star ptr B means it will be the value of the memory address of B, means it will be going to this location 20, because it will yield 2000, and star means go to the 2000 find the value, so it will 50, it will give you 2300, and star means go to the 2300 and yield the value, so it will give you the difference between these two numbers, so it will be 30. So whenever you are doing this type of difference, it is nothing but it will give you the difference between the values of the variables which the pointers are pointing to. And whenever you are performing these operations, simply you need to get the difference between two memory address, and if it is an integer pointer, divided with 4, float pointer divided with 4. Now we'll see the similar example with the character pointer, because each character will be 1 byte, so for character pointer we'll be dividing with 1. So if instead of this integer variable, if it is a character variable, what it will be happening, the star ptr and star ptr B both will be the difference between the number of characters you can place between this memory space. So if it was 100, right, for the character pointer, like if it was done on the character variable, right, so character variable are 1 bytes, it all are 1 byte, so each time the pointer is moving one step forward or one step backward, it will go to the previous location of the character variable in the memory. So it is always traversing with the 1 byte longer. So here with this 100 memory space, how many character variable you can store? It will be 100. So or in terms of your pointer differences between the two character pointer, it will yield the number exactly between the two difference between the two memory address. So here it will be, the resultant value will be 100, right? So this is the way we can do the calculation whenever we are going to perform the subtraction operation on the two pointer variable. Always remembers, two pointer you can only subtract if both are of similar data type, and then the resultant value you have to divide it with 4 in case of integer and float variable, and for character variable the resultant value will be the same as the subtraction value between the two pointer variable, and it will be always comes as a absolute value, because it's not the mathematical operation on the numbers, it's the mathematical operation performing on the, we are performing on the address. So its value will be absolute value we will get after printing this operation. Now I am going to discuss another interesting concept about comparison of two pointers variable. This concept will be very useful whenever you are writing data structure programs using pointer variable, for example linked list or stacks or queue programs, where comparison between two pointers variables are very important to understand, because we want to know sometimes in our program whether the pointers are pointing to the same memory location or the values are stored in the pointer are same or not. So now I will explain here step by step that what each of the statement is doing here. Here we have defined a integer variable. So suppose this is an integer variable and this is the memory representation of the integer variable 3000. We are storing 10 here and the location name is A, right? This is the first statement. Second statement, we are storing a pointer variable that is ptr. This is the ptr1. Suppose this location in the memory is 7000. What's the value we are getting stored here? 3000, the value of the address of A. Second pointer is nothing but another pointer we are declaring here ptr2, and we are storing the value of the memory location of A. Suppose it is getting the memory address of 9000 and we are storing the same memory address of A, and the name of the location will be ptr2, right? So these are the first three statements. Now what we are doing here, we are trying to compare between the two pointer variables. What this statement will do actually, this statement will compare two memory address, like what this will result as a memory address, because the pointer variable value is nothing but the memory address of A, so it will result as 3000. And then we are comparing with another variable, pointer variable, that is ptr2, and what ptr2 will return, ptr2 will return the another memory address that is pointed by the ptr2, that is nothing but 3000, right? So here we are comparing inside the if statement whether these two numbers are equal or not. Again I am repeating my statement. Here we are comparing whether this pointer is equals to this pointer. So this first pointer will return the value stored in the pointer, that is 3000, and we are comparing whether this 3000 is equal to the value stored inside ptr2. So the value of the ptr2 is nothing but 3000, so we are comparing these two numbers. So this statement will result as a true because both are same number. So this printf statement will getting printed that similar memory address. Another thing I want to tell you, whenever you are making this type of comparison, it should be the pointer should be of similar data type, because whenever you are performing the comparison operation or subtraction operation on pointers, the both of the pointers should be of the same data type, then only you can write this statement, otherwise compiler will throw the error during the compilation time. So this statement we have understood that both of the primary address will be returned and they will be compared, and if it is true, this printf will work, because if will return as true. In this statement, what is the star ptr? Star ptr is nothing but asking compiler to go to the memory address and give me the value, because star is nothing but this operator is address, value at address. So value at address means it will be going to the location of 3000. ptr will return 3000 and star ptr means it will go back to this location, so it will give you 10, right? First statement, whether it is equal, it is we will make the comparison with the value of star ptr2. So star ptr, what is the ptr2? ptr2 will also return 3000 here because 3000 is stored, and then star means value at address of 3000 means it will go back to this location. What is the value stored here? It is 10. So this statement also will return as true because both of the numbers are same, so this printf statement will be getting printed. So what we understood here, whenever we are making a comparison between two pointer variables, first of all, the both of the pointer variables should be of the similar data type, and it getting compared, the memory address will be returned from each of the cases, and then the memory address will be getting compared as a number. Both numbers are same means it will true. If the both numbers are different means it will be false, because memory address is nothing but the unsigned integer numbers, right? And whenever you are comparing with the pointer value at the pointer memory address means star ptr means it is going to retrieve the value of the variable where it is which memory location it is pointing to. So this operation will be converted to retrieve the value of the variable it is pointing to. So here we are comparing the values of the variables that both of the pointers are pointing to, not the memory address, and then the values will be retrieved, and then both of the values will be compared, and if the both values are same, then it will give you the true result, and the next statement will be performed inside the if statement. So this is the way we can do the comparison between two pointers variable. Now we'll discuss the operations that we can't perform on the pointers variables. So these are the operations we cannot perform on the pointers operation. First is addition of two pointers. Two pointers variable cannot be added. We have seen that subtraction of the two pointers variable of the similar data types are allowed, but the addition of the two pointers are not allowed. Multiplication of a pointer with a constant, when you are multiplying a pointer with a constant value means 3, 4, 7, 8, whatever the constant value you can imagine, you cannot perform the multiplication to a pointer. Division of a pointer with a constant means you cannot perform the division dividing a pointer variable with a constant value, means you cannot divide a pointer with a constant value, means any number you cannot divide. Now I have written few statement here. Integer a is equal to 100, pointer star ptr is equal to ampersand of a, b is equal to 10, and star ptr is equal to ampersand b. Now I am going to discuss these are the addition operation cannot be performed the two pointers. What does it mean? That it means we cannot perform this operation pointer a plus ptr b. This will throw an compilation error, because you are not allowed to add two pointer variables. But sometimes you may come across with the pointers variable where the values of the pointer values of the variables it is pointing to can be, those addition can be performed. What I mean to say, star ptr a plus star ptr b is allowed. See the difference between these two statements. What the first statement is doing, it is the addition of the two memory address, right? Pointer variable is returning the memory address it is pointing to. But what this statement is doing, it is returning the value at the address that pointer variable pointing to. So value is nothing but it's a numeric number. You can perform the mathematical operation on the numeric number. So whenever you are writing this statement, this statement is not dealing with the address. This statement is dealing with the values stored in the particular address that pointers is pointing to. So this operation is pretty much allowed, but this operation is not allowed. Similarly, you cannot write this statement ptr is equal to ptr a into 3. This statement is not allowed, but similarly this statement is allowed. But if you are writing star ptr into multiplying with the 3, this statement is allowed. Why it is allowed? Because star ptr is not giving the memory address. You cannot perform the multiplication with the memory address. Here start PTR, this PTR is returning the memory address, and you are asking the compiler to perform the multiplication operation on the memory address. But whenever you are performing this operation, what it's actually doing, it is actually doing the multiplication of the value with 3. So you can write simply, you can write this statement star PTR is equal to star PTR into 3. So what you are doing, you are going to change the value stored in the location where the pointer is pointing to. For example, suppose here in the memory map you have here 100 and the location is A, and suppose this is 3000, and here you have this pointer variable pointer A, PTR A is this location, and the location is 7000, and what is it storing here? 3000, right? So what this statement is doing, this statement is you are asking the compiler to multiply this 3000 memory address with 3. That is not allowed. This statement is not allowed. But what this statement is doing, you are asking to store the value of this multiplication in the location of this one. So what it actually doing, star PTR is nothing but what it will go to the location where the value the value of the variable is stored. So this statement will be converted to similar statement as A is equal to star PTR means what it is returning. This statement is nothing but it will give you the location of where you can refer the location as the variable A, and then this statement will be converted to star PTR means it will give you the value of A, that is the 100. So 100 into 3. So you can imagine this star PTR is equal to star PTR into 3 is equivalent as A is equal to A into 3. So these two statements is completely different. Again I am repeating, whenever you are performing PTR A is equal to PTR into 3, this is you are asking the compiler to perform the multiplication operation on the address. But whenever you are writing star PTR is equal to star PTR A into 3, this statement you are equivalent to, you are writing as A is equal to A into 3. Why this is converted to A into 3? Star PTR means what? It is going back to the memory address of 3000 memory address. The name is nothing but A. So you are asking to change the value at this address. So this statement will be converted to A is equal to A into 3. What A means? A means the alias to the memory address. So what's the value of A will return here? A is nothing but 100. So star PTR will also give you the value of 100. 100 into 3 means 300 will be stored in the location of A. So this value will be altered, not this value will be altered. So what it will happen? Instead of in the 3000 location, instead of 100, 300 will be getting stored here. So this will be the new value of A. So this statement is allowed to perform. So there is a difference between the pointer operation on the terms of multiplication. Similarly, if you do this operation, PTR A divided by 4, right? If you are performing this statement, this is not allowed. This division is not allowed because you are asking PTR A means it will return the address. So division on the memory address is not allowed. But if you write star PTR A is equal to star PTR A divided by 4, what this statement is doing? This statement is nothing but star PTR, we are not giving the memory address. We are going back to the memory address where the star PTR A value will getting returned with this statement. So what is the current value stored here? So here we have the 300, right? So 300 is stored here. So we are asking computer to perform 300 divided by 4. So this statement is equivalent to, you are writing the similar statement A is equal to A divided by 4. Why it is A is equal to A divided by 4? Because star PTR is not returning you the memory address. It is going back to the location. The location is getting which is stored in the pointer. So this statement is nothing but it is pretty much equivalent to A is equal to A by 4, and you are asking the computer to change the value of this location. So it is nothing to change the value of the pointer. It is related to the change the value of the location that's the pointer is pointing to. So what it will actually do after this operation, you are asking the compiler to perform this operation will change the value of this location. So currently this location will be having 300, by after dividing with the 4 the value will store as 75, and this location will be 3000, and this will be the new value of A. So this statement, whenever you are coming across or whenever you are writing, this is pretty much fine, because this statement you are not dealing with the memory, you are dealing with the value stored in the memory. So this statement is equivalent to whatever the statement you are writing as a simplification of the variables operation you are performing on the variables. Similarly, you can perform the pointers, but whenever the pointer is prefixing with the value at address operator, then the address where it is pointing to the value will be getting altered. So this statement is allowed, but this statement is not allowed. So what we have seen here, addition of two pointers are not allowed, but whenever you are doing an addition on the values that pointer is pointing to, that is allowed. Multiplication on the pointer is not allowed, because multiplication a number to a memory address is not allowed. But whenever you are writing a statement of start PTR, that means you are dealing with the value stored in the memory address the pointer is pointing to. Their multiplication or division both are allowed, and that will change the value of the location where the pointers are pointing to. So these two statements, don't be confused with the statement where you are using the star PTR, means it will always converted think as this is you are performing on the variable itself, not the pointer. But when you are removing the star, you are going to deal with the memory address, and there you cannot perform the additions between two pointers, multiplication the pointer with a number, or division the pointers with a constant number. So these operations are not allowed.
Thank you for watching my video. If you like my video, please subscribe and click on the bell icon for more updates. If you have any query, please comment me on the comment box. I will definitely get back to you as soon as possible. Thank you for watching.